In this video, let's look at geometric sequences. Remember, geometric sequences are also called exponential sequences. And let's remember the definition of a geometric sequence. So the definition of a geometric or exponential sequence is that you multiply or divide each number by it to get the next number. Another way to say it is that there's a constant ratio between each successive term, constant ratio. So let's look at an example. And let's first, before we look at the example, let's look at the explicit formula. So the explicit formula is going to be a sub n is equal to a sub 1 times r raised to the power of n minus 1. So let's see what these terms mean. The a sub 1 is simply the value of the first term. And the r here is the common ratio. That is what you multiply by, or if you divide by, it'll be a decimal or a fraction. A sub n just says which term. It just stays a sub n, and the n there stays as well. So the only two things that you change to figure it out is a1 and r. So let's look at two quick examples. So the first one is write the explicit formula for this given sequence. And your first step here is you have to figure out, well, what type of sequence is that? So 200 to 100. So 200 to 100, that's a difference of 100, and that's a difference of 50 and 20. So it's not linear. So if it's not linear, the way you do it is you figure out if it's geometric. You can kind of see it's geometric. See how each one halves, right? 200 divided by 2 is 100. 100 halved is 50. 50 halved is 25. So it's geometric. And to find the value of r, you take one term and divide it by the previous term. So you get 100 divided by 200. And you can either call that 1/2 or 0.5. It doesn't matter. 50 divided by 100 is also 0.5. And 25 divided by 50, right? Each term divided by the previous term is also 0.5. So since each time you take one term and divide it by the previous term, you get the same number, then that's the common ratio. And the common ratio is 0.5, and we're going to use the formula r. So how do you write the formula? So you write down the formula. The formula is a to the n is equal to a1 times r raised to the power of n minus 1. a1 here is 200. R is going to be 0.5. You could also say 1/2 if you want to. And this is raised to the power of n minus 1. And here, unlike in the linear one, there's no simplifying to do, and that's just your answer right there. So if this is write the explicit formula, it's geometric, there's other steps. First, figure out if it's arithmetic, geometric, quadratic, or some other term. This is geometric. Write down the formula. Plug in the first value, in this case 200. Plug in the r, in this case 0.5. A question which in substance is the same but is asked in a different way and gives a different answer is this. Let's say you want to find the 20th term of a given sequence. Well, if you ask for the 20th term of the given sequence, the very first thing that you need to do is you need to figure out if it's arithmetic, geometric, quadratic, or something else. This one, if you notice this one, see how we're multiplying by 2 each time? 10 times 2 is 20. 20 times 2 is 40. 40 times 2 is 80. And whenever you're multiplying or dividing by a constant amount, that's geometric or exponential. So this is a geometric one. So once you know it's geometric, you're going to write down the formula. The formula is a to the n is a1 times r raised to the n minus 1. We're going to plug in the different values. a1 is the first term, so we're going to plug a 10 in. R in this case is 2. See how you're multiplying by 2 each time? So that's times 2 raised to the n minus 1, a sub n. So this is your formula right here. If you're asked for the formula, it'd be done. But in this case, you're not asked for the formula, you're asked for the 20th term. So what you do is you're going to take this formula and you're going to plug in n is equal to 20. And one difference in geometry is usually you have to use a calculator for this. And so this is a sub 20, or the 20th term is equal to 10 times 2, 20 minus 1. See, what we're going to do is where the n is, we're going to plug in the 20. 20 minus 1 is just 19, so that's 10 times 2 to the 19th. And And at this point, we've got to be really careful with PEMDAS. Remember PEMDAS? Parentheses, exponent, multiply, divide, add, and subtract. The key thing here is exponent and multiply. We have to do the exponent before we do the multiply. So we're going to do 2 to the 19th. Let's think about how we do this on a calculator. There's 2 different ways to do this. Probably the easiest way to do that is you simply play 2, and you use this button right here. It's called a caret button. It doesn't really matter what it's called, but it's like a upside down V. And then that's to the 19th. 2 raised to the power of 19th. Hit an equal. And that's going to be a huge number. So it's 10 times 5, 2, 4, 2, 8, 8. Then after you do it to the 19th, then you're going to multiply it by 10. And your final answer is going to be 5, 2, 4, 2, 8, 8, 0. That should be it. That was an 8 there. So that's going to be just about 5 million. You often get that when you get exponential functions, because the whole point of geometric functions is they grow very, very quickly. So if you're asked for the 20th term, you get a very large or very small number. Anyway, that's all what you need to know about geometric sequences.